Last time we had an overview of decision analysis. We looked at it as a philosophy, a framework, a process, and a methodology. Today we're going to discuss uncertainty. And the three topics we'll talk about is the basic concepts of probability, probability encoding methods, and discrete approximations. Next time we'll talk about decisions under uncertainty, looking at the decision basis, alternatives, uncertainties, and values, and then looking at two of the key frameworks, influence diagrams and decision trees. By the end of the course, you should be able to identify and frame the key issues of decisions, create doable alternatives, obtain decision relevant information in an unbiased manner, define values and trade-offs, analyze, evaluate, and compare each alternative, and then present a cogent case to gain commitment to action. This course will improve your decision making, modeling, analytical, and Excel skills. There are three basic ways to describe uncertainty. There's words, there's single point estimates, which are deterministic values. Usually you'll see these in budget and financial analyses. And then there's probability. The language of uncertainty is what I see probability. It's the unambiguous way to describe uncertainty. And the way I define define probability is it's a number between 0 and 1 used to describe an expert's state of knowledge or belief concerning an unknown outcome or event and uncertainty. Probabilities are between 0 and 1, and the probability of those events sum up have to equal 1. And then one of the key properties to know about probabilities is the conditional probability, which says P given A is equal to the P A intersect B, the AND of the A and B, events A and B, divided by the conditioning event B. Words mean different things to different people. What do the following words mean to you? If you were to take a few moments and write down what does almost certainly mean to you, highly unlikely, very good chance, probably, likely, probable, we believe, etc., etc., and we were to compare this in our class, you'd find that there'd be overlap, for example, between highly unlikely and probably likely. So there would be overlap on what these words mean to people. So what you end up with is ambiguous description of uncertainty. And what you'll see when you communicate with people about uncertainty, a lot of times they'll use words to describe that uncertainty. And now as you are aware that words mean different things to different people, I would guess in your workplace, work environment, you will probably ask folks for a little further definition of what they mean by some of these terms. The example I have is the CEO talking to a vice president, and the CEO says, "If I had known that likely meant 40 to 50% to you, I would have not bid on that contract. For likely means 80 to 90% to me." The danger is that many forecasting problems, single point estimates such as averages or base case values, are inadequate to reach sound conclusions. Apt, etc. 1979 article is a really wonderful article. The Dangerous Quest for Certainty in Market Forecasting, Long Range Planning. Highly recommend you read that. Single point estimates are fraught with difficulties of balancing pessimism against optimism, and there's no single point estimate, however obtained, can reliably and repeatedly balance risk and opportunity. With scenarios, it's difficult to find the small number that truly span the range of interest. But probabilistic forecasting is really the only way, sensible way to evaluate problems when you have uncertainty. And most decisions have uncertainty because decisions are made for events that are going to unfold in the future, and hence they are uncertain. This is a nice little cartoon from Sam Savage's article in Harvard Business Review, and it says the flaw of averages, which states simply that plans based on the assumptions about averages, which is a single point estimate, conditions usually go wrong. So you can see that the flaw of averages says the average depth is 3 feet, you have probably a foot, and then next thing you know have 8 feet, and if you average all that together you get 3 feet, and this can be definitely dangerous in this situation. When we embrace uncertainty, our forecasts of factors influencing value are no longer expressed as single numbers, but rather as ranges or probability distributions. So what we'll see in deterministic analysis, which means no probabilities, probability distributions, is you have a model that says C is equal to A plus B. You have inputs of 39 and 47, and the output is the sum of those two, which gives you 86. One estimate for each input variable. This assumes away uncertainty. In the probabilistic analysis, you can have A and B be random events, random variables or uncertainties, and when you input these, you get a new output out, C, which is also a uncertainty or a probability distribution. The range estimates for each uncertainty, well, what we use is range estimates for each uncertain input variable, and this explicitly captures the uncertainty. And then I'll close this with Francis Bacon's comment, if a man will begin with certainties, he will end with doubts, but if he will be content to begin with doubts, he shall end in certainties. How do we obtain probabilities? Probabilities are obtained from subject matter experts. The subject matter expert considers the data that he or she has available to them and also their knowledge and experience. They can also be based on his research results, historical data, and they will rely on expert judgment. You'll have the expert's judgment regardless if there's data there, because he or she needs to determine that that's the right data. And like I said earlier, probably is a number used to describe an expert's state of knowledge or belief concerning an unknown outcome or uncertain outcome. Expert judgments of an uncertainty are essential but often biased. When you use probabilities for using the probabilities for expressing uncertainty is not natural for most people. This has been shown over and over again in psychologists providing experiments and showing that people are not very good at expressing uncertainties using probabilities. They have systematic biases in the way they perceive uncertainty, and they're usually not aware of these biases and can't easily control them. People can be helped to recognize situation where their biases are likely and corrections can't be made. And one of the results of these biases is overestimation of your knowledge. Invariably, people will look at the information they have and the data and the knowledge and their expertise and systematically make their distribution too narrow. They will overestimate their knowledge. They will think there's not that much variability in the uncertainty they're looking at. So the red dotted line represents, dashed line represents what typically you'll get back from an expert unless you can debias them and help them spread out the data. The more details of that, these biases in the probability encoding process, are posted on Moodle under the PowerPoint slide deck called Probability Encoding Process. So the way we can get around these biases that people possess, and it could be experts or people that aren't even experts, it doesn't matter. We are biased in how we assess probabilities. There's a formal probability encoding process that's been around, I guess if you look at the papers referenced here, since 1975, so that means it's been practiced probably in the 60s to 70s and refined and been used quite a bit. So the typical 5-step process that we use is motivating. You introduce a task and identify the motivational biases. Structuring is extremely important because you're clearly defining the variables and assumptions, and what we call passing the clarity test. My experience has been, for example, I guess talking about price with the marketing person, there's different types of price. There's the retail price, the net price, the price that they get, and the list is as long as your arm of the different definitions of price. So you need to be on the same page in what you mean by that. And then to counteract these, the conditioning step is where we counteract the cognitive biases, and you divide and conquer. An influence diagram, which we'll talk about later, is a way to break up and divide and conquer the uncertainty that you're looking at, and then you make a point to elicit ranges, extreme scenarios. The encoding step is where you develop the probability distribution, and the assessment order is extremely important. You want to go to the extremes as much as possible. Ask what's the min and max, what's the absolute worst, absolute best, And then you don't want to go to the center, because if you go to the center, like the median or the average, if you ask those questions, what's your median, what's your average, one, that's a hard question to answer for an expert, but it also anchors them on that number as opposed to going to the extremes. Group settings don't usually work very well, but there are ways around that. And then ideally you'd like to have a face-to-face meeting. Then next is probably a Skype or a phone call, then email and questionnaire. And then the last step is where you verified the distribution accurately reflects your beliefs.